For the past 3 months for my dissertation, I have been researching power flow in data centers and creating a piece of software around to interface with a library, a power flow library. So if I just get a bit. So just a quick overview on power flow. Power flow or load flow, which can be used interchangeably, is calculating is a formula that is used to analyze the power that's coming in to a server, data center, anything that uses electricity, and then calculates the how efficiently the power usage is throughout the power network. Usually, not only does it highlight how efficient the network is, but also it can be used to calculate components that might be overutilized, like too much voltage going into the system, or so it can highlight those areas of improvement, and it can also help companies save money in infrastructure and how much they might spend on how to store the power and that. So a study that was done showed that for data centers, the average cost could be around 18,200 for 7 kilowatt rack, to around 52,000 for a 20 kilowatt rack, depending on, of course, the overall power usage of the data center and the servers used. So the reason why I put power flow was not only what we're doing here now, but also it's just something interesting. And that, I mean, I was interested in servers for a while, and researching this showed how complicated it can be. It's not always just about servers and that. It's of course saving money where you can, and how much power each server costs and that. So the library that I'm using to calculate the power flow is called PandaPower. So this is a Python-based library, and the reason why I chose it was because out of the ones that I've researched, this one was the one that is kept up to date. It's constantly getting updates, and it uses Python, and that's quite important because so Unity, which is the engine I'm using in order to visualize everything, uses C#, and there's a lot of documentation on how to get C# to communicate with Python and vice versa, and yeah. So again, just go through some challenges. One of the challenges, of course, is trying to find an appropriate way to get C# to communicate with Python. So quick rundown, I used Python, what's called Python.net, which allows what I needed to do. The project also basically has a Python built into it, so it actually has the Python language and engine in itself. So it's all self-contained, so you don't need anything external, and that, which is quite important, because you don't want your clients to having to download something externally to get everything running. I mean, currently, which you'll see here soon, I'm mainly a programmer, and only do a little bit of UI every so often. So the UI is very simplistic currently, but but because of its simplicity, it's very straightforward on what each bit does. So it's very clearly labelled. Of course, PandaPower has its own limitations. One of them being that it doesn't support UPSs, and a lot of servers do, or data centers use the UPSs and similar stuff in order to keep the servers running. But that doesn't mean that it might not be supported later down the line. As I said earlier, that PandaPower is constantly being updated, so they might eventually be able to implement a UPS component. And with how the software is set up, that could be easily updated to support that. So I'll just go to the demonstration now. So just exit out that really quickly. So this is the software. Sorry, I'm just pick it up. So it does have its own standalone thing. It does work with that, but this is just easier to demonstrate. So simple controls, WASD to move around. You can use the scroll wheel to zoom in and out. So if you right click, sorry, you will find a create list. So these are all the current components that the system does support. This is enough to make a very simple network. So you got like the bus, external grids, what's the line to connect components together, the load, and the transformer. So so you can directly hook them up like this, and then if I get another bus, so these two are now connected. If I right click on the line component, so this is the modify menu. So any variables that need to be changed, and that you basically go through and change them here, and then you click on refresh, and that sends all the information to the Python script. And then, so if I, so yeah, you can build them up like that. If I just click on new to wipe everything out, if I just load up the minimal example very quickly, so you can save and load networks that are made in the software. So if I just click on generate grid, you can see, so this is all the information regarding what's been generated and all the component information, so you can always verify if it's been successful. You can export this network. So PandaPower supports certain types of file exporters for file types to export to. Currently, this supports 3 out of 5 ways to export. So Pickle, Excel, and JSON, and that. And then you've got extra options for certain file types. So you can encrypt JSON if you want to. And then once you're happy with that, you can just click on export, give it a name, and then just save it, and it will export it. That. So if you go to generate the results, so this is where you would calculate any power flows. This is where the actual power flow system comes into play. Currently, the software only supports the TDPF power flow, but PandaPower does have other options like DC power flow, to name one of them. So you'll be able to pick them from a drop-down menu, and then you'll be able to customize what options you want to use. So if we just generate, as you can see, so this is all the information that the report would do. Yeah, so if I then just click export, same thing, it'll save it to a text file. It's formatted. So if I just quickly export this, for example, and just do results. Yes. one, for example, and save that. I'll be able to show you that in a moment. Yeah, so you'll be able to, I said, modify this. So yeah, and then if I just quickly just stop this for, sorry, stop this for a moment. Sorry, it takes a little while for the system to stop everything, because you need to make sure that Python shuts down and that. Sorry about that. So if I just minimize that for a moment, sorry about this. Let's just, where is it? Oh yeah. If I just, there we go. So it will, though this is the results of, this is like the file format for the results. So you can easily see what settings there were. And then these are the actual results formatted, so you can understand them and that. So that's basically what it is. So this is the minimal example. So this is the custom save system that, that the software uses. Again, easy to understand. So you can, if there's like an issue or something, you can modify it or that. But you can directly modify the stuff, like the variables and that, if you think you've done a mistake. That yeah, so that's currently what the software does. So if I just go back to the, so there are a lot of things that need to be sorted out. So for example, there's trying to import, so PandaPower supports importing the exported file types that I just showed, like that pickle, Excel, and JSON. Currently, the system does not, software does not support that, but it can do. It's just going to take a extended amount of time due to how complicated it will probably to import everything. Also, of course, UI is another thing, because you want the software to stand out, so people recognize it just by the UI. Quite important. UI is just really bland. Of course, supporting all of the components as well that PandaPower supports, and that, as well as just like bug fixes and oversights, and yeah, among other things. So yeah, that's it. So thanks for listening. Is there like any questions?
I'm just curious about, how does this deliver information into the digital twin? How is what you've built useful to the twin itself? Why do people care about this?
Oh, about like the power flow. Well, as I
think talk about the kind of unimagined use case for the power flow as well.
So ideally, you'll probably have this in a, I don't know, you'll have like other software to do certain calculations and that. Ideally, you'll have this in a workflow, so you can plot this anywhere that you want. Okay, I want to test out power flow at this stage, and then you can import it in, do all your calculations there, and then export it out, and then put that into another piece of software, and so on and so forth. Of course, like besides some of the benefits of the software, of course, is finding out which components might be getting too much voltage to be delivered. So, of course, too much voltage to a component can sometimes be all right, depending on how much voltage it is, but it degrades the life quicker, and then you might have problems later down the line, and then it's expensive to fix them. So it saves money overall. One of the other things, of course, is saving money in like how much power and that. So like you don't want to, especially when you're making like a new server or new layout or whatever, you don't want to overspend on like the power backup systems and that. You only want to spend as much as far as a little bit of an overhead on UPSs and stuff like that. And of course, how I think that's connected up. Of course, you don't want a component to be on a very high voltage bus, and that will cause many issues. And it can also point out certain issues with the network. So especially when you're extending the network or completely redoing it, because you don't want to extend the network and then there's not enough voltage going through everything. So power flow is quite.
So it allows you to kind of zoom in on what's happening with the power flow.
Yeah.
And it gives you a tool and you can play with that. If you're not very technical, you can just put the pieces in and then you get a nice report at the end of it.
Yeah.
The report will give you a sense of at every point in the electrical network, is there enough power or is there too much power? So that's important for sizing breakers in a data center. It also gives you a sense of how much power total you're using. So the minimum example Assured obviously has an external grid. The amount of power your data centers are going to get charged based on how much power they pull from the grid.
Mm-hmm.
The amount of power they're pulling from the grid is not equal to the sum of the power used by just the servers. It's all of it. It's the reactive power used in the transformers. It's the losses in UPSs. It's every single step of the way you're using, you're having efficiency losses in your electrical network. So it's about understanding that as well.
Yeah, what's happening where there's room for more efficiency, where there are losses. And then when it talks to the digital twin, what's uploaded? Is it the report that you generate that's then uploaded? Is that kind of your output? That
would be a future work. Basically, yes, the report would be something you could upload. Mm-hmm. Ideally, if it was going to talk to the digital twin, it would need to do time series simulation, but that would probably be in future work because that's one of the...
Yeah, that could be, the software can be expanded to support anything that needs to be added in that research into.
Yeah. So how much did you know about all of this before you started this project? Because you've had to learn how it works as well as how to build it. So
very minimal that besides the coding stuff. Power flow, completely new to me. On top of that, just learning the PandaPower library and learning Python on top of everything else. So I had learned basically 3 things. But it was definitely a challenge, but interesting on how everything works. And I'm quite happy that, especially with the getting Python to actually work in Unity and like C# and that was a challenge. Visual Studio, the coding visualizer that I use in order to code everything, did not like the built-in Python. For a time, it was reporting that, oh yeah, the library doesn't exist. But I imported it in, it works. It doesn't exist. So I had to basically work off the manual and that. It worked. It just, Visual Studio was being fun.
Yeah.
So,
so it's been a great learning experience.
Yes. Yeah.
How to make things work together and, fit all the moving parts together.
Yeah, it's given me some ideas as well to make tools to help people, like for example, get Python to work in Unity better. So I'm thinking of making a tool for Unity or an asset package which just allows people to just import the Python engine into it, and it does everything else for you. So
that's a nice, useful, unexpected output, isn't it?
Yeah. I mean, I like making tools for Unity. And that, so it's given me a lot of ideas especially for my portfolio as well. So
I think you said were you going to release this as open source as well?
Yes, I will. I will open up the GitHub repository as well, so people can take a look at it. And that, I mean, don't be surprised that the code is very messy. I've learned a lot of things over the course of the 3 months. So if I was going to properly do this, I would probably start from the ground up with what I already know. So
yeah, that's an interesting point. What would you do differently after having gone through this process? If you had your time again, what order would you do things in then?
for one thing, probably do a little bit more, try and make how the components connect to each other more robust. There are some oversights that I discovered a little bit too later that I can really fix. For example, if two endpoints of a component overlap each other when trying to connect to a bus, one of them or both of the components will not be registered as connected, and that will cause some issues. So yeah, with that, with the current software, you have to be very, very gentle with it. So probably just add more robust code to sort of look into that. I've got a console thing that you can take a look at. So probably some more error codes and warnings and that can be outputted onto that, so you can take a look if there's any issues. Definitely some more better error code information. If there's like an error when generating the network, it does a generic error code, like try to do it 10 times and failed, but it doesn't tell you which area failed. So trying to extract what information for that and then output that to the console, and just general better coding structure, the better types of what's called inheritance, those scripts, and yeah, and of course better documentation on what each of the scripts and better naming conventions as well. So there's a lot I've learned, but definitely I would definitely, if I was going to do this properly, or not properly, but like continue development, would definitely start from the beginning and build up from what I already know.
Anyone else got any questions?
Stations on this.
I think it's good. I mean, if you come out at the end of like a project like this and go, oh, there's so many things I would change, I think that just means you've learned a lot. So success.
Yeah.
Yeah. And it does sound like you've learned a lot. There's a lot of, there's a lot of moving parts to this project as well.
Yeah.
So I think you've like wide in your approach, which is nice.
Yeah. I mean, probably one of the major challenges besides doing the PowerFlow stuff is learning Python on top of that. Getting out of some habits from C# in order to get Python to work due to syntax differences. Yeah, Python's interesting to code in. Very interesting to code in. But because of what I've learned now, right now the system, the Python side of thing is actually in one Python script. It's not a good idea. Add loads of globals. Not a good idea to do that. So that's one area where I will put each of the component types into their own script, and that to neaten up the main script. And,
so you're learning a little bit, but is it like modular design?
Yeah.
Yeah. So that if one fails, then the rest of the system's okay. Kind of built in resilience to the code.
Yes. Yeah. So there's a lot I've learned with making sure that the parent class works and that. So yeah, they're without going too technical.
It sounds like what you've learned is very transferable, though.
Oh, yes.
Some of it's about Python, but some of it's just about good practice, right?
Yes. Yes.
Have you enjoyed it?
Yeah, I mean, that's a hard question, because coding, you can, there's areas where you really enjoy it and everything works, and then there's just like, oh God, you're not working. And then like it's enough. I mean, overall, yeah, I definitely learned a lot, and I've enjoyed doing the software, and like especially finding out how C# can communicate with Python, because C# has a built-in system for communicating without going into too much detail. And like, yeah, especially with the Python.NET library, that was a challenge among itself. Early on, at one point, I broke it. Don't know how. I just broke it because I was experimenting, and thank God for backups and like GitHub. The GitHub repository, I can just refer everything. I was like, oh, thank God it worked again. But that was like an interesting challenge.
And were you able to call on Nour and Steve for advice then when it broke? You know, what do I do here? Is this a common problem that you kind of learn in the beginning?
Like one of the major issues that I had at one point, which we basically went through, and that was where Visual Studio was reporting that the library didn't exist. I ensured that it was installed properly on the Python side of everything, and what we did was we just copied and pasted the Python example into the script, and it worked. So it was just Visual Studio. What I figured out was that it was an issue with Visual Studio getting confused with my built-in Python that I got on my laptop versus the built-in Python in the actual application, and that I think there's some oversight in the code in the Visual Studio that doesn't recognize or doesn't get the information correctly with that. So that was a challenge because I didn't have any syntax help, and so I had to do a lot of guesswork with method calls and just hints from the manual. So definitely a big challenge, but managed to get it working, and so everything worked in the end.
Okay. Kind of the question. Apologies if it's a stupid question, but when you did your example setup, you had your data output. It seemed like it generates quite a lot of data, even from a fairly sort of simple setup. Would there be a way, like in future, to maybe like visualize it or have it? That could be a stupid question.
Is this like when generating the network or the actual report itself?
You generated an example report off the
setup. Yeah, the report, yeah.
Yeah. And it puts out, it looked like it put out quite a lot of data. And that was for a fairly simple setup, I think, wasn't it?
Yes. I mean, what it's doing right now is just grabbing all of the stuff that gets outputted. So Python would return all of the information that all the results.
Yeah.
So like the lines, the buses, and stuff like that, and then it just dumps. And I got like a method that basically just grabs all the information, makes it pretty, and then just outputs it. That's just what PandaPower outputs. I mean, what I can do, future thing is just to do like you can have maybe an option for for each component, so you can like tick, okay, I want this information from the buses, for example, and only this information, and then you can output it that way. So, I mean, I can add on to that. I mean, I'm very I've been coding in Unity for years, so I know how I can easily visualize how you can cut down on the reports or only have specific information that you want to report, basically. So yeah, you can cut it down, but right now it's just grabbing everything, formatting it, and then outputting it to a text file currently.
Okay.
But it's the text file that the computer wants, right? So it just wants it to be in the format of the computer.
So
the twin can read.
Yeah, I mean, the text file is the most easiest one to read, and that's so even you can read it. But if for example the twin needed a specific file type, all I need to do is just research what the file type is, what needs to be put in, and then just modify the code in order to support that. So yeah, I can easily expand it. the most important things with this software is, of course, having a lot of the foundations done first. It took me 2 months just to get the foundations started before I could even get any of the results and network generation. Because if the foundations not set up correctly, when you try and add things onto it, which you'll have to either redo the whole foundation or re-visualize it. It could cause a massive redo of the whole code base in order to get it all working. So you have to be, so the foundation is really important. But yeah, I've learned a lot. So I know what I want, and more research will allow me to get the better foundations on the go.
Okay,